So this is on page 21. Page 21, example number 7. We're just continuing on the sine law and cosine law application. It says here, your friend lives in an apartment building in a downtown Winnipeg. From their balcony, they spot you on the ground at an angle of depression of 72. So yesterday we talked about angle of elevation, and we said angle of elevation is when you looking straight and then all of a sudden you look up. And then now angle of depression is when you're looking straight and then all of a sudden looking down. So that's what angle of depression is, going down. So angle of depression of 72 degrees. If your friend is 30 meters from the ground, determine the distance that you are standing from the base of the building. Now, that story kind of ties in here, okay, with the picture, because the picture is given to us, which is great. Let's see if that works for us. It says here, the friend, from their balcony, they spot you on the ground. So this is your friend, and then they spot you down here. And the angle of depression of 72. So angle of depression of 72 degrees is from horizontal looking down. So that's what it is. And then it says here, your friend is 30 meters from the ground. Your friend is up there, 30 meters from the ground. So that's 30 meters there. Okay, that makes sense. This is not 30 meters. This is 30 meters from the ground. Determine the distance that you are standing from the base of the building, from here to here. So this is the distance that we're looking for, the x. So going back to this one here, this is our triangle. We notice that this angle up here of 72 degrees is outside the triangle. So we have to bring it inside, but we can't just bring it inside. What can we do? 90 minus 72, and that's we call calculate the complementary angle. Yeah, okay. So that we have the angle inside the triangle. So 90, where did the 90 come from? Here, that's a 90 degrees. And then 72 plus something will give us 90. That's going to give us 18 degrees. Okay, so the angle inside the triangle here is 18 degrees. Now, how can we figure this out? What's our strategy here? What's our strategy? Can we use sine law or can we use a cosine law to figure this out? Sine? Okay. Anything else? Why sine law?
Because you can get the one matching pair.
You can get the one matching pair, okay. What can we get? Do we have a complete pairing?
Yeah.
Okay, so we got this angle.
Or you could get
This one is missing. I'm gonna do what Jesse did. That. Okay, so this angle here corresponds to this side. Okay, that's all I could think about. What angle is this? 90. So we have this angle, but we don't have that side, so that's not a complete ratio. Now this part here, you got a side, but no angle. So it seems like we're kind of stuck. So how do we do that? How can we do? So we know that this is 90 degrees. Yeah, so what we could do is we could actually figure this angle out. Figure that angle, and to do that, it's the sum of the angles in a triangle adding up to 180 degrees. So if I take 180 and I take 90 away and I take 18 away is equal to 72 degrees. So 72 degrees there. I'm going to color uses 72 degrees there. Now we can see that we have a complete ratio. This is our complete ratio. So let's calculate that piece. Oops. So it's going to be 30 divided by sine of 72 equals x divided by sine of 18, right? Because these two and then these two, the one that's half complete. So how can we figure out x? I'm going to cross multiply that. So cross multiply. So the 30 will be cross multiplied by sine 18 divided by sine 72. 72. Okay. So this one in here, we said, I'll just go on the side here. So x is equal to whatever this number is. Okay. That becomes 30 sine 18 divided by sine 72. It's 9.75. 9.75 meters. Okay, so 9.75 meters. From the sound of it, we're getting familiar with figuring out, should I use cosine law or should I use sine law? So I think it's a good thing, right? Are there any questions before I move on to example 8? You okay? Let's take a look at example 8. You are in charge of designing a wooden ramp to go over a section of heaved concrete on a sidewalk. The design is shown below. Powered wheelchairs can traverse the ramp only if the angle of the ramp makes with the sidewalk is less than 15 degrees. Will your design be able to accommodate the people in the powered wheelchairs? And justify our answer.
That one can go both ways, I think.
Okay. Can go both ways. So this is the ramp that we're trying to figure out. It has to be less than 15 degrees. So this angle here, theta, has to be less than 15 degrees. If it's more than 15 degrees, it's hard to go up the incline. Okay? So that's what they're saying here. The ramp has to be less than 15 degrees. So how can we figure that out? Is it a sine or cosine? Let's take a look.
But the
Cosine.
two angles would be equal.
Yeah, so this one here is just gonna be underneath the thing. So this is where the heaved gravel is, heaved concrete at the bottom. So they're saying that this from here to here is about 8 feet, 8 meters. Not 8 feet, 8 meters. So is it sine or cosine? Now what do we have? If we have
Each angle would be 13.5.
Interesting. Okay, interesting. Where's my thing? is what I'm looking for. That's an interesting thought because from the looks of it, it looks like this is 4.7 and this is 4.7, right? It kind of makes it look like they're isosceles triangle, but there's no indication that it is. So it's something that we can't really assume at the moment. Yeah, they look like they're both 4.7, but might not necessarily be. So can we use a sine or cosine? I'll redraw it. Somebody says sine. Can somebody say cosine? Cosine has to have a sandwich. Do we have a sandwich phenomenon here? Where the given angle is in between the given sides? No. So we don't have that one. And cosine law, to find the angle, it all three given sides has to be given. So that one is not that. So it has to be a sine law. Okay, so this is a complete ratio, complete. You got the side and then the angle, and then the other one is half complete. So let's set it up. Yeah, it is sine law. Starting off with the side, 8 meters divided by sine of 147, and then 4.7 divided by sine theta. Gonna cross multiply. We're going to cross multiply this. That becomes 8 times sine theta equals 4.7 times sine 147. Okay. So that didn't quite solve for theta. Okay. So what we're going to do is we're going to get rid of the 8. So divide by 8. Divide by 8. So sine theta is equal to all of that. And we're going to get 0.319975. Okay, well, that can't be the angle. It's too tiny, but so that can't be the angle, right? That's actually the sine of the angle. So what we're going to do, we have to get rid of sine. To do that, got to do the sine inverse. Sine inverse.
You press second function, sine inverse as you equal.
Yeah, that's right. So we have to do second function, sine. It'll take us a sine inverse. And then the answer, so it's going to be 18.66 degrees. 18.66 degrees. So that angle is 18.66. So do you think it's a good Good angle? Do you think it can accommodate the people on a wheelchair? Shaking your head, why not? What's the requirement?
It has to be less than 15.
Yeah, the requirement has to be less than 15 degrees. This is so the answer is no, the design will not accommodate the powered wheelchair because angle is more than 15 degrees. The angle is more than 15 degrees. We can't do it. Okay. Is that good? So, what have we done so far in this sine and cosine? Well, there's a context, there's a story behind the situation, and then you have these to guide you, right? If you have a all three side phenomenon, all three sides are given, this is what your strategy is. If we have a sandwich phenomenon, right, where the angle, given angle is between the two given sides, this is our strategy, finding out the side. And if it's not these two, it's going to be most likely the sine law. It has to be the sine law. Okay? I think next time I teach this, I'm going to start with cosine law. Because I think cosine law are easier to spot. Okay, so that that concludes that lesson. We have assignment 4 for you to work on, okay, for us to work on. Some of the questions there, they have the picture given, which is great. Okay, so this one too, it's great. Oh, this is an exam. I remember this question. This is from a provincial exam. And then this one, provincial exam question. It's kind of nice. This is some stuff for you to work on. Okay. Oh, again, provincial exam question and a provincial exam question. Oh, we got a taste of provincial exam questions. Okay, so I'm making myself available to you if you have any questions. But you give it a try, right? Show your work and then show your final answer.